Hello everyone. So right now I am showing you the setup that we are going to work on to build the non-inverting amplifier. So we have here the power supply. So we'll turn it on. And you can see that we have three power supplies, variable one, fixed one, and variable one. So these two probes for 5 volt, and this one we adjusted it to have 5 volt. We have these two probes, the multimeter, and we have here the oscilloscope. Sorry, this is a function generator to generate signals, and we have the oscilloscope here. So we have the circuit here. So first we need to attach the external power supply. We'll put power supply here and one here. So let's start. So we have one here. Let's connect the red line to the positive. The black one probe to the negative. Then let's put the other power supply here. This is the second one. Let's put the positive and the negative. So right now we have here 5 volt and we have here another 5 volt. So we need to connect the positive here with the negative here, the same as the image that we have shown before between the two alkaline batteries. So we connect this one, this positive, to this negative. Then at this point this is going to be the common ground, and we will call that this line is the -5 with respect to the 0 or the common ground, and this is going to be the +5 volt. So for now let's put the circuit. So we have here the op amp. This is the op amp. So we will put the negative VCC to the ground, terminal 4. Then we will put here, this is a +5, we will put it here on the VCC. So a -5 and +5. Then from here we need to get two equal resistance for the feedback resistance and the other resistance. So you will look here for the two resistors that are equal. So I selected these two. They are the same to have a closed loop gain of 2. So at this point I am going to connect this one to the output and to the negative terminal of the op amp, which is the second terminal here. Then I will have from the second terminal, we need to put it on the ground. So let's put it here somewhere. Then we need to get the common ground. We need to get a wire to connect it to the common ground. Actually, let's put this resistance here, because this is the common ground. This is the common ground. So for now we need to inject the input signal. So So let's put 2 probes for the input signal. So we will have this one on the plus terminal of the op amp. So this is to get the input voltage or the input signal, the sinusoid signal, and this one is going to be on the ground itself. Oh, we don't have to do it right now. So let's see the function generator. You can see here we have 2 channels in the function generator. We press this one. We have to make sure that this one is on so that we can get a signal from the function generator. You can see that this cable, it has 2 probes. This is for the positive and this one, the black one, for the ground. Okay, so let's place it here. So you have here one for the positive plus terminal, and this one is going to be for the common ground, which is here. So let's adjust this one. As you know, we have plus and -5, which means that, and we have a closed loop of 2, which means that the V output shouldn't be more than 5 volt. So let's go here and select the sinusoid wave, a sine wave, and let's change the, well, right now we have an amplitude peak to peak 1 volt. To change this value, basically you have to press on this button and you select amplitude, then you start to put some value here. So let's put, for example, 1.5 volt peak to peak. So it's here, and the offset, make sure it's 0 so it's not shifted up and down with the DC value. So by now we have a signal, but it has 2 high frequencies, 250 kilohertz. Let's make this one 1 kilohertz. So let's make it just let's make it here 1 kilohertz. Let's put this button, so it's 1 kilohertz right now. So we have 1.5 voltage peak to peak and with 1 kilohertz injected inside the signal itself, in the circuit itself. So let's go for the oscilloscope. We have this oscilloscope, it has 2 channels. So right now we are running 1 channel, the yellow one, if you want, and we'll make the first channel for the input signal. Let's take the probe. So you put this terminal for the positive and this extension for the ground. So let's put this one. So the input signal, basically, which is coming from, let's have a wire to get the input signal. Let's have it here. Then let's put this one to the ground, the common ground. So right now it's the common ground. And we are supposed to see right now the signal. Let's press first auto set. So you can see the sinusoid wave right now. And these 2 buttons, this one's to change the position of the horizontal value, the time domain, right and left, and this one to change the scale of the time, and this one for the scale of the amplitude, up and down, and this one to change the position up and down. So let's decrease it so you have all the signal, and if it's moving like this, you need to change the trigger level, so adjust it until it becomes fixed. Okay. So right now it's kind of fixed, so you can see it. And in this small table, it tells you each section here, it has a 500 millivolt per division. Okay. So let's for now to get the output signal. So we will have the second probe, and we will connect it to get to measure the output signal. So here, this side is the output, so we'll connect it here, and we have to connect the second or this extension to the common ground. So let's have this one to the common ground. So right now the oscilloscope does not show anything, but if we press this button, it will show the second channel. So right now we have the second channel, and let's basically make auto set. So right now we have the second signal here, as you can see. Let's make the trigger to make it kind of constant, or like fix it on the screen. Okay, so here we can see that they have two different scales. So to compare them, let's make both of them the same scale. Yeah, let's make this one this scale first. Let's combine both of them. We'll place on the screen, and we'll make overlay stack. So right now we have the two signals on the top of one another, and let's make the divisions equal. So we can see that the channel 2 has 100 millivolt. So let's decrease the channel 1 little bit. So here we will select channel 1, and we will decrease the scale of the amplitude. Let's make it 1 volt per division, and let's change to channel 2 to have the same scale. It becomes blue, and let's turn the knob until you have 1 volt per division. So we can see now the two signals. However, there is a problem that we are facing here, that the output signal should be bigger because we have a closed loop gain of 2. So let's investigate what is the problem here. So we found the problem that the resistors that I have used were too big, had 1 mega ohms each, which basically it's too big compared to the input resistance for the op amp. So we cannot use that big resistors. So I decreased the value, and I have used right now 1 kilo ohms instead of 1 mega ohms. Okay, so at this point the signals right now are more proper. So basically we'll make both of them in the same scale. So let's make this one basically 1 volt per division. Then let's change to channel 2 to make it 1 volt per division. So you can see right now the signal itself. The yellow one is the original signal, which has a voltage of 1.5 volt from here, and which basically 3 volt from peak to peak. And we can see that the other signal is double the size, which means it has a gain of 2. So by doing this, we have done the circuit of non-inverting amplifier, and this is the oscilloscope again, the function generator, and the circuit. And before going, if I would like to measure, for example, the phase difference between two signals that I am visualizing here, okay, usually I press here on the cursors. Then you will have 2 cursors, and they mention that this is for channel 2, and we can basically change the slider or the cursor left and right, and this one, and we can see that each one gives information about how much voltage it measures. and the time itself, and here it gives you the difference in time and the difference in voltage. So you could measure the difference in time between 2 points on a channel 2. Here, for example, we have this point and we have here this point. We can get the difference in voltage and the difference in time, and using the time difference we can get the phase difference between the two signals. These two signals are in phase because it's not an inverting amplifier, so the phase difference is 0, but not always this is the case. Okay, I hope you enjoyed building this circuit of the non-inverting amplifier. Thank you so much.